Welcome everyone. In this video lecture, we will solve a GATE 2013 question which is basically based on a open-based circuitry in which one NPN transistor is also given and one resistance is given 1 kilo ohm and supply 5 volt. So we have to find the V output. So this was a very simple question and the corresponding options are minus 15 volt, minus 0.7 volt, plus 0.7 volt and 15 volt. So in this simple question, first we have to start with the some basic concept. Suppose this op-amp is nothing but simply a inverting amplifier based circuitry. It is somehow inverting amplifier, we can say. Okay, why I am saying this one is inverting amplifier? Because if we think this one is a this NPN transistor, this NPN, I'm just making this NPN transistor, which is given here, okay, and this point is our V output. So I am focusing this one. Okay, so we have to find the V output. So one can also say this one, the V output is nothing but simply plus or minus, or we can say there will be a ground and there should be this V output, or one can say plus or minus this one is V output, and this end is nothing but simply base and collector, and this is our emitter. And as we know, the VBE voltage, base emitter voltage, always 0.7 volt, because this one is silicon NPN type transistor. Okay, so if we know this thing, so if we apply KVL in this loop, okay, means we if we go for this, okay, so one can directly write the KVL equation, say plus V out plus V out, then this voltage is plus or minus VBE. We can say this one is plus or minus VBE. Once again, I am doing this one is grounded, plus or minus VBE, and this one is nothing but simply V out. So one can write plus V out plus VBE equals to 0. Okay, simple KVL. Kirchhoff's voltage is plus V out plus VB plus minus. So plus VB. We are taking assumption like that. So we can say V output equals to minus VBE, and VBE value is 0.7. So this value will be simply our minus 0.7 volt. So our option, which one will be correct? B1 will be the correct one. So this one is all about this question. One can also think like that. V output, if this was a inverting amplifier, so it should be minus RF by R1 V in. Okay. So we can say the output is a negative one as a function of resistance RF, R1 and V in. So there will be a negative sign, there will be a negative sign, so that's why there is a negative sign. Okay, and now there is the voltage due to this plus or minus VBE. So if you apply the Kirchhoff's voltage law, it will come like this. Okay, 0 point minus 0.7 volt. If the another way to think, the current in this one, in this 1 kilo ohm resistance, will be I equals to 5 minus 0 by 1 kilo, that is our 5 milliampere, and this one is the virtual ground, so this potential will be 0 and there will be no current due to high input, so all current will be go through this one. 5 milliampere. But no need to think about this current 5 milliampere is going on what. Just apply Kirchhoff's voltage law in that section because we are interested in the weird value, so we can directly find the this type of thing easily by applying KVL. So again I am just focusing on the KVL plus V out plus V out. Okay, then again we are going to this side plus VBE to 0. Okay, so this one again writing V output plus V output plus VB equals to 0. Very simple. Or V output equals to minus VB. Okay, so this one is the correct answer for this question. So thank you for watching this small video. So you can think like that for this simple question, but the key thing you should know about some Kirchhoff's voltage law, Kirchhoff's current law, because sometimes we have to use the simple KVL KCL concept in solving such type of question. So thank you for watching.